Hi folks, this is Calc 1, Checkpoint Quiz 9. Number 1A, we're asked to find y terms, y prime, in terms of x and y, if we're given this equation. So this equation, we believe, implicitly defines y as a function of x. It may be several different functions depending on what piece we're looking at. But when we're looking for y prime, remember we're thinking we want dy dx. So we want the derivative with respect to x of y. And so instead of solving for y, which would be darn near impossible to do, we're going to start with our original equation. We're going to take the derivative of both sides with respect to x. So the derivative of 2x squared with respect to x is the derivative of cosine of pi xy squared with respect to x. So going through the rules of differentiation, if I substituted in an x on this side, the last thing I would do would be multiply by 2. So multiplication by 2 is the first derivative rule I'm going to apply. So the constant multiple rule says I can pull that outside the differentiation. On the left-hand side, I'm taking the derivative of this expression. If I knew an x and a y, the very last thing I would do would be to take the cosine of that. So I need to take the rule, or find the rule for the derivative of cosine. And since what's inside the cosine is different than the variable of differentiation, I'm going to use the chain rule. The chain rule says, if I want to take the derivative of the cosine of something, it's negative sine of that thing times the derivative of that thing with respect to x. So this is negative sine of pi xy squared times the derivative with respect to x of cosine pi xy, cosine of pi xy squared. The derivative of what's inside is just pi xy squared. Okay, back on the left-hand side, we can use our power rule there. And then we're done taking derivatives there. On the left-hand side, let's see what's going on. If I substitute in an x and a y, the last thing I do is multiply by pi. I'll factor that out front. And here's where you really have to remember that we're assuming y is a function of x. Right? So that's the literally implicit assumption here. So I have a function of x, x, and then another function of x, y squared. Since they're multiplied together, that's going to be the product rule. So I have 4x equals negative sine of pi xy squared times pi. Now I'm going to apply the product rule. The product rule says you take the derivative of the first factor times the second plus the first times the derivative of the second. So I have 4x equals, I'm going to migrate this pi over here. It's multiplication, so I can do that. The derivative of x with respect to x is 1, so I have 1 times y squared for the first term. And then I have x times the derivative of y squared with respect to x. So once again, I use the chain rule. Y is a function of x. The variable of differentiation doesn't match that variable. So the derivative of something squared is 2 times that something times the derivative with respect to x of whatever the thing was. So 4x is negative pi sine xy squared, or pi xy squared, and I have y squared plus 2xy, and that's y prime. So at this point, the calculus is done. Now we need to settle the algebra, which means we have to solve for y prime. Alright, so in solving for y prime, we can distribute this mess through. So I'm going to have negative pi y squared sine of pi xy squared minus 2 pi xy y prime sine of pi x y squared. So we get everything with y prime on one side, everything else on the other. And so I can add the 2 pi y prime and subtract off the 4x. And finally, I can divide both sides by everything except the y prime. So I get y prime equals this thing. And I'm trying to look to see if there's anything I can factor out and cancel, and it doesn't appear to be anything. So it just is what it is. Now, of course, when we do any kind of divisions in algebra or calculus, we have to make sure we're not accidentally dividing by 0. So what would mess this up here? If x or y is 0, certainly that's bad. If the sign of this quantity were 0, certainly that's bad. So the question we have to ask ourselves is this going to work? Because in part B, we want to find the equation of the tangent line to this curve at the point 1/2 comma negative square root 6 over 3.